Hi everyone, welcome to Maths with Mr. Hanna. As you can tell in this video, we're going to look at exponential and logarithmic graphs. And for both types of graphs, because they're both quite similar, we're going to approach them in the same sort of way. We're first going to make sure we get the asymptote in the right spot. We'll then make sure that we get the shape right. And really what I mean there is consider which way it's been reflected. And lastly, we're going to make sure we calculate the axis intercepts correctly. And if we do those things in that order, we'll go very well. So first we'll consider an exponential graph. And we'll start with a very basic one here of 2 to the power x. And you might remember that exponential graphs always have a horizontal asymptote. So this one has an asymptote at y equals 0. And then they have this shape here. So a few things that this is just the basic exponential. Down here it will approach 0, it approaches the asymptote, so make sure your graph goes really close to your asymptote there, and then it just grows exponentially up to infinity. Now if you consider here the y-intercept when x is 0, well, anything to the power 0 is 1, so that point must be 0, 1. And you can find some random other points too. For example, 2 to the power 1 is 2, 2 to the power 2 is 4, 2 to the power 3 would be 8, so that would be way up here somewhere. Okay, now there's no way to get any negative result from an exponential equation without there being some sort of subtraction. So on this second one, you notice how it's the same equation but take away 8. And that take away 8 really controls where the asymptote is, which is what we always do first. So for this graph, you'd first put in your asymptote at y equals minus 8, and you then know it's just a basic sort of exponential look. Make sure it approaches the asymptote properly there. Then you can calculate the axis intercept. So if you put in 0, 2 to the power 0 is 1, 1 take away 8 is of course minus 7. You could also find the y-intercept if you wanted to. You basically want 2x to be equal to 8, and that occurs at 3. So if you put in 3, 2 to the power 3 is 8, 8 take away 8 is 0. Great, so there's that graph. So you can see if you just add or subtract a number, that will determine where the asymptote is. So I could have, just to do a second one here, I could have done like a 2x plus 5, for instance. And the first thing I would do there is put in the asymptote up here at y equals 5 and put in my, my graph. So asymptotes, they just move up and down. On this third one, you'll notice the translation is actually going 1 unit to the right. And the reason I include this is because it does not change the asymptote. The asymptote is still here at y equals 0 because it's only moved sideways. And you can't really move a horizontal asymptote sideways anywhere. But it nevertheless does go in the positive direction, and so the graph will just look like this. If you put in 0, you get 0 take away 1, and so you'd actually get, for a y-intercept, you'd get 2 to the power minus 1, and you know from your index laws that is a half. So this point here, 0, a half. But the shape of it looks exactly the same, and the asymptote hasn't gone anywhere. So step 1, get your asymptotes written in correct. So make sure the asymptotes are right as your first step. Second step, you've got to get your shape right. Now we've already seen the first one, y equals 2 to the power x. And you'll notice there's 4 main different shapes you can get, different reflections you can get. By putting the negative sign out the front here, that's a reflection over the x-axis. In other words, it makes the graph upside down. So that's a reflection over the x-axis, upside down. Reflect over x-axis. Okay, so that's the same as you've seen before. If we look further down, you'll notice that we have the negative is now in front of x, not out the front of the whole thing. This one actually is a reflection over the y-axis, a side-to-side reflection. So the asymptote, again, same position, but a sideways reflection. And once again, this is at 0, 1. So here, that is a reflection over the y-axis. Okay, you can probably guess this final one because it's got a negative sign in both locations, so it is reflected in both directions. So I'm kind of imagining first upside down, then side to side. So the asymptote is in the same spot as before, but now looks like that. It's reflected in both directions. So we have normal exponential reflected over the x-axis, so upside down, and reflected over the y-axis side to side. Sometimes both. All right, there's some more things to not get tricked by, so let me quickly go through them. Here we've got 3 different graphs in different colors. First 2 to the power x, we've seen that many times now. In black 3 to the power x. Well, all 3 to the power x does, it goes through the same point here, but it grows quicker. So, whoops, so it actually grows a bit quicker. And then if the base is 4, it also grows yet quicker still. But in none of those cases with the different bases did the shape change. It's always got that shape growth look to it. So there's no real need to worry yourself about those, other than to say that any of those bases, any base really, just creates the same sort of a shape. Or to be more precise, I should say every positive base greater than 1. So it doesn't matter if it's 2, 3, 4, or 5.5, or anything like that. The shape will be the same. But what about this case where we've tried to do a negative base? It turns out this doesn't even make sense, but let's think why. First, if we put 0 in, well, anything to the power 0 is 1, so our first point is 0, 1. If we put 1 in, minus 2 to the power 1 is just minus 2, so the second point is 1 minus 2. If you square this, it becomes positive 4, so that's up here, 2, positive 4. 3 will be minus 8, so you can see that this is starting to just go up and down and be a bit crazy. This becomes even crazier if you think, well, what happens here? What happens when x is a half? You would have minus 2 to the power of a half, and remember, powers of a half means square root, and here you get a really big issue because you can't try and do the square root of a negative number. So this point doesn't exist, so between these values, there's just nothing. So this one, in fact, you can't graph, and you'll never get one with a negative sign inside the brackets. You can't have a negative base. All right, well, here's another interesting one. We've got the base being a fraction. Well, here it's a bit sneaky actually, because you've got to realize that this could be written, this fraction of a half could be written as 2 to the power minus 1 with that index law. And therefore this is the same thing, in fact, as a reflection over the y-axis. So this will in fact look like this. Exactly the same as what we had earlier. So the base being a fraction is actually a secret reflection, but any other different base will just have the same shape. So really, as we said earlier, there's only 4 shapes standard, and the 2 different types of reflections, reflection in the x-axis, reflection in the y-axis, or perhaps both reflections at once. So 4 options, and you've got to figure out which one yours is. All right, once you've done the asymptotes, once you've figured out which type of shape you've got, you've then got to figure out the axis intercepts. So let's do full 2 examples then. So this one here, we can see that we've got a minus 12, and so our asymptote must be at minus 12, and we can therefore put that in straight away. Next, we think about the shape, and there's no negative symbols, no reflections, so it'll have the standard sort of a shape. And now we need to find the axis intercepts. So first, the y-intercept, of course, occurs when x is 0. And as we know, anything to the power 0 is 1. So 3 take away 12 is minus 9. So y-intercept, 0 minus 9. You can see that there's an x-intercept as well, so we'll better calculate that. Of course, make y 0. And so you can see here that we have an x value of 2. And so this point must be 2, 0. Fabulous. Okay, well let's move on to this one here. Similar idea, you can see this one's been translated up 8 units. So we start with our asymptote here. You can see that once again, there's been actually no reflections. It's got the standard shape. So we'll put in the standard shape once again. So we looked out for the reflections. Now we find the axis-intercepts. So we first off will find the y-intercept. So we've got a 5 to the power 1 plus 8. And that's just 5 plus 8, so that's 13. Now you notice that there's actually no x-intercept, and you can see that from the graph already. If you tried to solve this to equal 0, you would find no solution. Now, since there's only one point, it's always good form to find another point. So we'll just find another point. We'll find the point when x equals 1, because that's usually a pretty easy idea to try and find. That'll give us 1 plus 1 is 2, so that's 5 squared plus 8. So that's 25 plus 8, which is 33. So there was another point here, which is a 133. So there we go. If we don't have two axis-intercepts, we better find an extra point. And it doesn't matter which one you choose, so pick one that's easy. All right, we've now finished with our exponential graphs, and we'll consider now logarithm graphs. First off, we need to remember that logs are in fact the inverse of exponentials. You could think of them as the opposite of exponentials. So if you have 2 to the power 3 equals 8, that's the same as doing the log with the base 2 of 8 is 3. So log's sort of saying, so asking what the log is kind of saying what's the power, and the power is 3. Another way of thinking about this is, of course, as inverse functions. So if you swapped x and y and then solved for y equals 2 power x, you get y equals log base 2 of x. Now, as you remember, for inverse functions, it's a swapping of x and y. And if you swap x and y for all of these coordinates, you'll kind of get a bit of a shape of the log. So first, the y-intercept becomes an x-intercept. No longer 0, 1, but 1, 0. This point 1, 2 becomes 2, 1. And the point 2, 4 will become 4, 2. And the point minus 1 half will become a half minus 1. In fact, the asymptote that's a y equals 0 becomes x equals 0, because every x swaps with a y. So the asymptote is now x equals 0, and it's now not a horizontal asymptote, but a vertical asymptote. And so the graph looks a little bit like that. So it approaches the asymptote down the bottom here, and then goes off in this positive region. You might notice that this is like a reflection across the y equals x diagonal line compared to the first one. That's another way of thinking about inverse functions. So everything that used to happen to the exponentials is going to be the opposite when it happens to the logarithms. So instead of having a horizontal asymptote, we'll have a vertical asymptote. Instead of the vertical translations being the thing that matter the most, it's the horizontal translations which really matter the most. Excellent. Okay, well, let's get started, and everything's going to happen in very much the same way. We first need to get our asymptotes right, then we need to get our shape right with the reflections, and then we'll find the axis-intercepts. So as we've seen, a basic log graph has a vertical asymptote at x equals 0. It starts near the asymptote down the bottom, then goes off, and the standard x-intercept is 1. Let's take a look at this one. You'll see that it's been translated in the positive direction 4 units. So the first thing we'll notice is the asymptote has changed where it is. So it's now over here, at x equals 4. The shape of the graph hasn't changed, and if you tried to figure out, well, if you think the easiest way is if you think that it started off with an x-intercept of 1, but now it's translated 4 units, it must now be at 5. Or if you wanted to take a little bit more time, to find an x-intercept, y is 0. Taking 2 to the power of both sides gives a 2 to the power 0 equals x minus 4. So that's 1 equals x minus 4, and therefore x must be 5. So you could take a bit more time. The third one, you see that it's actually translated to the left, so it's gone backwards 8 units. So here the asymptote must be here at x equals minus 8. It's got the same logarithmic shape though, and you can now find that this point must be at minus 7. And now there's also a y-intercept. So if you try to find the y-intercept, you can. That occurs log 2 of 8. This is kind of asking what power gives a base of 2 to be 8, and that is, of course, 3. So 0, 3. Okay, so the asymptote, it's important that it could move left and right. It's a vertical asymptote, so it moves left and right for a log. The asymptote can't move up and down because it's vertical anyway. So having a plus 4 doesn't really do anything. The asymptote just stays where it is at x equals 0. It still kind of has that log shape, but you may not be able to find the x-intercept quite as easily. If you make y 4, you get a minus 4 when you make y 0, sorry. And here we have a log base 2 of x. Take 2 to the power of both sides. 2 to the power minus 4 equals x. And 2 to the power 4 is 1 over 2 to the power 4. And so that is 1 over 16. So this value is 1/16, 0. But the main point I'm trying to make is that the overall shape and the asymptote have not moved and haven't changed. So it's really just translations that go horizontal that matter for logs. The opposite of exponentials. All right, secondly, and very importantly, we need to get the shape right. So get the reflections right. The standard shape, of course, looks like this. The negative out the front, as we have heard, is the reflection that goes over the x-axis. It's the upside down reflection. So that'll now look upside down like that. When the negative sign is in front of the x, that is, of course, a reflection over the y-axis. So it is a reflection that way. A side-to-side reflection. Here you can see we've got a negative in both positions, so it will be both reflections. A reflection both upside down and side to side. So it will look like that. So by the way, on those ones, the x-intercept must be, of course, minus 1. Brilliant. So there's just 4 shapes. The standard one over here, and then, of course, the 2 different reflections, or combining both together. All right, finally, we need to consider the axis intercepts when necessary. So let's do 2 examples to bring everything together. Of course, firstly is the asymptotes, then the shape, then the intercepts. So this one you can see has been translated this way 5 units. So that's what we'll put in first. The asymptote is now over here at x equals minus 5. There's no reflections, no negatives out the front or next to the x, so it's got the standard log shape, which looks a bit like that there, so just for my little reference. And so the standard log shape is a bit like this. We'll now find the axis intercepts. We can start with the x or the y-intercept, it doesn't really matter. Out of habit, I usually find the y-intercept first, it's often easier. Okay, now at this stage, there's no way to simplify a log base 3 of 5, because there's no power with a base of 3 that gets 5. So what we've got there has to just be the answer. So now for the x-intercept. Okay, so we'll add 4 to both sides. Now we'll divide both sides by 2. Okay, now we'll do 3 to the power of both sides. 3 to the power of 2, 3 squared is 9. Subtract 5 from both sides, gives us 4. And at this stage I've realized that I've made a mistake somewhere, because otherwise it doesn't make sense. Yes, and here's a very important part. I've actually not made a mistake. It's that my original graph was wrong, and because this y-intercept was a confusing number, I didn't realize that that y-intercept was in fact negative. So I've got to be a little bit more careful than what I was, and realize that this log graph actually looks a bit more like that. So perhaps a happy mistake, so that you can learn from it as well. All right, and that x-intercept there at 4. All right, and this is a great lesson that sometimes it can actually be helpful to find out the axis-intercepts before doing the graph. All right, last one here. Now here it's written a bit sneakily, because if you look carefully, you realize the negative isn't referring to take away 25, it's referring to negative x. So that actually will be a reflection in the y-axis. So to make this more clear, I would always rewrite these ones just to make it a little bit more obvious what's truly going on. Okay, as you can see, it's actually gone in the positive direction, 25 units, but it's been reflected over the y-axis, that side-to-side reflection. So first the asymptote, which is at x equals 25, and this one has actually gone that way. It's been reflected that way. So we've got to find the x-intercept and the y-intercept. First we'll find the y-intercept. So that's when x is 0, which is log 5 of 25, and that's 2, because 5 squared is 25. So y-intercept up here is 2. Now we'll try and find the x-intercept. So that's when log 5 of 25 minus x equals 0. Do 5 to the power of both sides. Anything to the power 0 is 1. Oops, equals minus 24, and so x must have been 24. Okay, so that's it for graphs of exponentials and logs. Hope you learnt a lot, and I look forward to seeing you soon.